Okay, so the exam is a week from today, and this topic we're gonna like delve deeper into. We started in on it on Monday, but we're gonna delve deeper into it and do a lot more difficult problems. That's the hardest thing that's gonna be on this exam, okay? So because of that, I wanna make sure you get adequate preparation time. So we'll do quite a few examples today. You go do the homework as much as you can, do as many practice problems as you feel comfortable doing, and then come in on Friday. We'll do a couple more practice problems. We'll do the last section, which is a concept section, so it's not particularly difficult. And then over the weekend, you'll do the homework. Then we'll have a review day or question and answer day on Monday, and then the exam on Wednesday. Okay, so that's kind of the next week, how you need to plan things out. But I just want it to be really clear that you need to be doing some of these practice problems in the homework in the next couple days, okay? All right, so let's just finish out this problem that we ended with last class. So we determined what x was by figuring out that we knew what the equilibrium concentration was here, and we knew what we started with, okay? So the initial change is going to equal the equilibrium, okay? So if we have x being 0.35, that means that we're going to plug in x for the values for H2 and CH3OH, the change values. So this one will be 1 minus 2 times 0.35, or 0.30. Okay? And then in this case, it's 0 plus 0.35, so it's just 0.35. Okay, so this was end of class last week, or Monday, last class. Okay, so we're gonna do the next 2 or 3 that have the ICE table set up for you, well, have the beginnings of it set up for you already. And then on Friday, we'll get to ones where it's more in words and you have to set up the ICE table. But this one is relatively straightforward. What you're gonna see today is that like setting up the ICE table is kind of the first part of these problems, figuring it out in terms of x. But then solving for x, doing the algebra, is like a whole nother half of the problem. So there are gonna be some of them where we can make approximations that make the problem a lot easier to solve, or like kind of use tricks of algebra to make the problem a lot easier to solve. There'll be at least one here that's pretty complicated, and technically we would have to use the quadratic formula. So I'll talk about that when we get to it and say when you will and won't have to do that. Okay, so we're gonna go ahead and start on this one. And I want you to follow through on the steps. Let's actually talk about those first. Follow through on these steps, okay? So they already set up the basic ICE table for you in this one, but most of your problems, all of the problems you're gonna do on an exam for sure, are gonna be in words. So the ICE table is a way to organize that information. You're saying, do I know anything about the equilibrium amounts? And what do I know about the initial amounts? So you're gonna do that first. Then you're gonna decide which way the reaction goes. Does it go to products? Does it go to reactants? Because that's going to affect how you define the change. The thing it's leaving is the minus x. The thing that you're making is the plus x. Okay, so that's step number 3. I don't know why they don't have this in here, but obviously I need to rewrite these. Then you need to we'll say define, because that's the word, define the equilibrium values. So like in this example, we define the change, but then we say, okay, 1 minus 2x is what the equilibrium value is. Okay, and then the last thing is going to be solving for that x value. Okay, so follow those steps. I'm going to give you a couple minutes to start in on this. Once you get to the algebra part where you're solving for x, because ultimately you've got to plug this into the k expression. you've got to plug these equilibrium values into the k expression, and then that's when you can solve for x. Once you get to that, if you can figure out the algebra, great. If you get confused, that's okay. I'm going to show you a trick on how to do this one. Okay, so I'm going to give you a couple minutes to work through that, and then I'll start working it up here in a minute or two as well. Just one more minute. I've put up where I want you to get to at least, or maybe plugging in the equilibrium values, and then we'll do the math in just another minute. Let's go ahead and talk through this, and then I'll show you kind of the trick with the algebra. And you'll want to like see enough of these different tricks that you can use so that you don't end up making it more complicated than it needs to be. Okay, so steps. First one, set up the ice table. That was done for us. Second, define which way the reaction is going to proceed. So in this case, it has to go to products because there aren't any products yet. Okay? So I drew the arrow to remind myself of that. If you have one that's 0, you know you're always going to have to go to make that. if you had non-zero numbers for all of the chemicals, that's when you have to do the Q versus K and figure out which direction the reaction proceeds. So because we're forming products, that means we're using up the reactant. So that's why this is minus X and minus X. These guys are getting used up. We're starting with 0.2 molar. We're going to use some of that and have less than 0.2 molar at the end. So with our little, balance point thing, we're here right now, and we're going to go like this to some degree. It's 0.1, so a little bit reactant favored. Okay? Then we're going to make some of that as well, but because the coefficient is 2, we say plus 2x, because for every 1 molar of these guys, I make 2 molar of that. Okay, so that's defining the change. Next step, defining the equilibrium. So I do initial and change together, so you're adding them basically. So 0.2 minus x for this one, 0.2 minus x for that one, and 0 plus 2x is 2x for the product. Then you want to write out K symbolically. Do I have that on the list? Okay, when you solve for X, that's going to require you to write out K symbolically and plug in equilibrium values. Okay, so write that down on your steps. This one is from the textbook, and I should have put in my own spin on it on this one. Okay, so I finished off the ice table by defining the equilibrium. Then I wrote out K symbolically. So products raised to their coefficients over reactants. And then I plug in these equilibrium values into those different chemicals. Okay? So 2x, make sure you have it in parentheses because it's the quantity 2x squared. And then 0.2 minus x for both the ones on the bottom are equal to the K value. That's given up here, right? Kc equals 0.1. Okay, this is a little bit of the poop your pants. I said the other word in another class and I felt bad. So the poop your pants moment, where you're like, oh, I hate math. This one has a very nice trick that makes it really easy, okay? If we couldn't do the trick that I'm about to show you, you would have to solve the quadratic formula. And I'll tell you, there's going to be one in class and at least one on the homework where you will have to solve the quadratic formula. I am not going to put one on the test where you have to solve the quadratic. There will always be a shortcut to avoid that because I don't require you to have a graphing calculator, and I'm not going to make you do it by hand because it takes way too long. Okay, it would use up all the time for the exam. Not all the time, but too much. Okay? All right, so the trick here is to recognize that these two are the same thing. And so I actually could rewrite that as 0.200 minus x squared. So if I have a squared on top and a squared on bottom, I can just take the square root of both sides to get rid of that squared here. Okay, so right now this is what I have, and I'm going to take the square root of both sides, because remember that's algebra. I can do anything I want as long as I do it to both sides. And that'll leave me with 2x over 0.200 minus x equals the square root of 0.1, which is 0.316. Okay, for the sake of making sure you remember how to do this kind of algebra, take another 2 or 3 minutes and solve for x now that we have it simplified down. Because once you're just talking about a singular x, not an x squared or an x cubed, you definitely need to know how to do that kind of algebra. Okay? take a couple minutes and solve for x there. Okay, so I'm going to go up to a blank spot and solve this. So if you're finishing it up, just keep doing it and check your answer when you're done. If you want to follow along with me, that's fine. Let's see, let's move it to the middle here. Okay, so I'm going to multiply both sides by 0.2 minus x to get that to cancel. And I'm left with 2x equals, what is that, 0.0632, right? Minus 0.2, yeah, minus. Okay, now I'm going to combine like terms. And isolate the variable. And I get 0.0273. I'll leave that up there for a second. So this isn't the final answer. I think the question says, what are the equilibrium amounts of each chemical species? So you would need to now go plug X in and find out what the amounts are for each of those. We'll do that in just a second. But often people will like just look for X. Sometimes, you know, questions intentionally make it like they're asking about a chemical species equilibrium concentration, but that is like 2 times X. So obviously on a multiple choice exam, like X would be one of the answers and 2X would be one of the answers. Okay, so let's go back down, just double check what the question asks. Yeah, determine the equilibrium concentration of each species for the following conditions. So let me move this down a little bit and we'll put those answers in. Okay, so X was 0.0273, so 0.2, I'm doing this part here, 0.2 minus 0.0273. So the equilibrium amount of N2 is 0.173 molar. Same thing for O2. And for NO, it's X times 2, or 0.0546. Did I remember what X was right? 0.273, yeah. Okay, so that would be your answer. Now on a exam, it's not going to ask about all three. It probably would just say, like, what's the equilibrium amount of NO? Okay, and you just have to do 2 times X. Okay, so hopefully you can see there's like 2 kind of big parts of each of these problems. Get the equilibrium set up, get it plugged into the K expression, then the second part is actually doing the algebra. So I would say the algebra is going to be the bigger struggle for most people. Just keep that in mind. That's a big reason why you need to do a lot of practice problems. And that's all we're doing today is practice problems, and then on Friday, beginning of class.
So is those answers, does that relate to plugging in the X values of the X? Or
Yes, exactly. So I found X and then plugged it in here. So 0.2 minus that X value.
Yeah, was it 0.273 was the X?
I think it was 0.0273.
Oh, point.
Yep,
Yeah,
0.0273.
yeah, that's right.
Yep. And, think about, like, when you're plugging those in, that would have given you a negative value, right? 0.2 minus 0.273. So, like, you're never going to have a negative concentration. So that's one way to know, like, if you've done something wrong. Most of these problems, like, you're going to want to double check your work.
Yeah, it makes sense because 0.273 would give you a negative. So
Right. Yeah. Okay, so let's do another one of these. Now, this one is going to require the quadratic formula, and I don't care how you do it. If you love the quadratic formula and you want to do it by hand, by all means. You could graph it and see where it intersects the x-axis. What I'll do is plug it into like a calculator online, so I'll show you guys how to do that. I'm fine with you doing it the shortcut way. We don't have to solve it, by hand, and you're not going to have one of these on the test. You'll have kind of a shortcut way to be able to avoid it, okay? But you will have some of the homework, so. All right, so give you a couple minutes, go through all the steps like we did before, and at the very least, try to get it to the point of K, equals in terms of X, and then we can always do the algebra together. Okay, so I'm gonna go ahead and start working it up here. Okay, I definitely want you to be comfortable getting to this point. So we define the change has to go in the reactant direction. So we're subtracting off of the products 2 because the coefficient is 2, and then adding to the reactants. So now we define equilibrium by initial plus the change. And then we go ahead and plug those equilibrium values into the K expression. So that quantity squared and then over X. Yeah.
Quick clarification. So the X values with the change is dictated by the coefficients of
Yes.
the...
In the balanced equation, yep. So
Yeah.
2 and O, yep.
It's like with N2O4, there's like a 1,
Mhm.
and then with 2NO2, it's a 2.
Yep.
So it's,
Exactly. And the plus or minus is depending on which direction you're going.
Oh, because it's going from the NO2 to the...
Yeah.
So it has to be minus.
Yep.
Yeah.
Okay, so there is not a shortcut on this one. You have to do the quadratic formula because you're going to end up, you've got that squared on top and you've got the X on bottom. So what you do need to do to solve this, so again, in class on the homework, not on the exam, you need to be able to set this equal to 0, and then you'll have the coefficient for X squared, the coefficient for X, and then the one that's just a number, and those are all equal to 0, and then you have your A, B, and C. So whether you plug that into the quadratic formula, or plug that into a solver, or graph it, any of those will give you a good answer, okay? So I'm gonna go ahead and work that. You can follow along with me if you want, or do it on your own. So I'm gonna start by foiling the 0.1 minus, I'm going to write that as 0.1 just to avoid the zeros, minus 2x. And then that's going to be equal to 0.36x. So I moved the x over already. And now I'm going to FOIL the 0.1 minus 2x, which is where that x squared term is going to come in. So 0.01. And then minus 0.2x minus 2x and plus 4x squared. So really, I just have to combine like terms at this point in order to get that 0 on one side. And I'm going to write it as x squared x, and then the one without an x, the number. And then the 4 is your A, the negative 0.76 is your B, and the 0.01 is your C. It may have been a while since you guys have done quadratics, but hopefully it's coming back. So if you missed the step in the middle here, I was subtracting 0.36 off of both sides, and then I combined all of those x terms together. And then just rewrote it so it was x squared x number. So I'm going to take those values now and plug them into a solver. Remember that when you do quadratics, you end up with two values. You'll always have two values. X can never be negative, and it also can't be more than what you started with. So like we started with 0.1 molar, so one of the numbers is going to make sense, like it's going to be less than 0.1 and more than 0, and one of them won't make sense. Either it'll be more than 0.1 or less than 0, okay? Can't be negative, can't be more than what you started with. So I'm going to show you, like, I think I have one pulled up from before already. Not that one, that's cubic. There we go. Okay, I already have the values in here too. Okay, so A, 4, B, negative 0.76, make sure you don't forget the negative, and then C, 0.01, and you just hit calculate, and it does the quadratic formula for you, and then it tells you these are the two values. Okay, so 0.17 or 0.014. It cannot be 0.17 because you only started with 0.1 molar. You can't subtract 0.17 off of 0.1 or else you'll end up with a negative concentration, which is meaningless. Okay, so the correct X has to be the 0.0142. So we're going to bring that back over here. X equals 0.0142. And then I can go ahead and plug it into these values to figure out what those ending concentrations are. So for the N2O4, that's just X, so 0.0142. And for the NO2, it's 0.0716. So those would be the equilibrium concentrations of those two. Okay, on the next one, you will initially think that you have to do the quadratic formula, but I'm going to show you why you don't and an approximation that you get to make when K is very, very small, like it is here. So the K for this equation is 1.67 times 10 to the negative 7th, okay? So it's very reactant favored, all right? So let me actually change one of these values. Let's change this to get rid of that 0. So say it's 0.250, okay? It'll prove my point a little better. So go ahead and start this one and at least get to where you've plugged K, or you plugged the X, the equilibrium values, into K. Yeah. 0.0142. Mm-hmm. Okay, so I'll give you guys 3 minutes or so to do this one, and then we'll talk through it. Okay. Check and make sure you're good with up to where I get here and ignore anything in red. I'm just doing some quick math on my own. Okay, so you end up with a cubic equation here, which no one would ever expect you to solve that mathematically, like by hand. And you'll never have to do that for any of the problems either. I'm just gonna plug in the values I got into a solver real quick because I want to prove my point. So I want to give you an actual number for what this is. Assuming I didn't make a mistake here, I changed the number, so I don't remember if this is right. Don't know if it's right. Minus. That didn't work. I'm just going to make up a number. Okay. So when you solve an equation like this, oh, I forgot to set it equal to the k. That's why. Duh. All right. Well, I'm not going to waste our time and try solving that. So when you have a k that's this small, what happens is your x becomes really, really small. So let me just pretend what this is, because I know in general what the order is. It's something like 0.0001. Okay? Let me just write made up. Okay, so you know that if you solve this, it's not actually that. All right, so let's talk about what that would mean if you actually had a value that small. Now, does it matter that I made 0.0002 molar of this? And does it matter that I made 0.0001? Well, in the math, multiplying by a very, very small number matters, right? Like, if I have 2 and I multiply it by 0.0001, that's a big deal. It changes the number significantly. If, however, I have a very small number and I subtract or add a very small number to another number, does it make a difference? No. If I look at this and I plug in 0.25 minus 2 times 0.001, guess what I get? I basically get 0.25. If you carried it out far enough, it would be like 0.24999 something, okay? So what we're gonna do when the k is very small, and I'm gonna define k as being very small as k is less than 10 to the negative fourth, less than or equal to 10 to the negative fourth, okay? So if your scientific notation is 10 to the negative fourth or smaller, then we're gonna ignore when we have a minus x or or a minus 2x or a plus x or a plus 2x, we're going to ignore this term, okay? Not these ones, because multiplying by a small number makes a difference. But this isn't going to change the number significantly, and it will simplify the math a ton. So I'm going to go ahead and cross out this minus 2x, and then we actually should be able to solve it without too much trouble. Okay, so I want everyone to be really clear on what I'm doing here, because this is going to make life easy, and it's going to be like if you're on the exam and you get a problem like this and you're like, how am I supposed to solve this? It's a cubic equation. She said, I've still had people every semester, they'll be like, I thought you said you weren't going to give us quadratic equations on the test. I'm like, well, yeah, that means you're doing something wrong, okay? So if you get something like this, what one of the scenarios might be is that you get to make this assumption. You get to say, k is so small that x will be so small that it won't make a difference if I subtract a really small number off of this number. So I get to ignore that, okay? So I'm going to cross that out. And I'm going to rewrite this now as 2x squared times x over 0.25 squared equals 1.67 times 10 to the negative 7th. And that makes it so much easier. Now, this will still be cubic, but it doesn't have any other terms. It's just x cubed. So you can take the cube root to get rid of that x cubed. Okay? So in the last couple minutes, go ahead and solve this for x, just to prove to yourself that it's not that bad. And that assumption really does simplify things. And I will do that up here. So really, by making that assumption, we eliminated the x squared term, or the x term for that matter. So as long as you only have the x cubed, you can take the cubed root. So let me just show you like what it looks like on my calculator. So this is what I'm looking for, 3 root whatever, or yours might look like this, x and y. So then you would type in 3, this button, and then the whatever it was, 2.61. So I'll do it that way. 3, this root, 2.61 times 10 to the negative 9th. These two are no good because they're negative. So that one up top is the only one that's valid. Okay, so maybe you have to solve the quadratic, but only if the k is big, like 10 to the negative 3rd or 2nd or whatever, larger. Maybe if it's small, you get to get rid of that minus x or plus x. And then always look for little tricks that can help you avoid using the quadratic as well. Like, can you cube or square root the whole thing to get rid of one of those x squared terms? Okay, so plenty of practice in the next couple of days. We'll do 2 more where the ICE table isn't set up for you already at the beginning of Friday. And then we'll do the concept stuff that's left in section 9 for the rest of Friday. All right.
I had a question. Do you know which ones we actually shifted towards by just looking at it?
Yeah, so if one of them is 0, one of the chemicals is